Hello, everyone. This is Carla Sebastiani from Sustainable Innovations, and we will be going over a summary of the future of high-value bioacid production white paper that we have produced for the Perform project. So a brief introduction. As we all know, the chemical industry is a very important industry all over the world, and also for Europe specifically is also one of the most important industries. And even we have this quote that says that chemistry is life. So this industry really goes from little to global all over the world. Here we have the chemical industry sectors. So we have basic commodity chemicals, consumer products, specialty chemicals, and life sciences. Here we have, let's say, a little example of each. So basically, basic commodity chemicals are these chemicals that are mostly inexpensive and are produced in bulk, generally. These an example of this is polymers, petrochemicals, basic industrial chemicals, inorganic chemicals, and fertilizers. Then we have right at the bottom the specialty chemicals, which tend to be more expensive than the basic commodity chemicals because they need to fulfill a certain function. So these are designed for specific reasons. These obviously are more expensive and are not normally are not produced in bulk. Then we have consumer products, which are the products that are in direct sale, such as soaps, detergents, cosmetics, for example. And then we have life sciences, which are the chemicals that, for example, agrochemicals, pharmaceuticals, biotechnology products who have kind of like a bio application. Now, looking around, especially globally, at this part we are speaking globally, these are the chemical industry mega trends at the moment. So we have end user centric approach, customer centric operations, digitalization, sustainability, and volatile demand. Each of these is having an impact and is leading the chemical industry at the moment. For example, the end user and customer centric operations is supposed to kind of boost the brand awareness of the chemical industry to kind of focus more on the end user and customers respectively. We have digitalization, which is related to the digitalization of the processes that are, let's say, inside of the industry. We also have the volatile demand. This is a very specific thing that has happened in the last years due to COVID-19, which has really made us realize that many markets are very volatile. And now we saw this during the COVID pandemic because many industries had to kind of make the switch in order to, for example, sell masks and antibacterial soap. So this has affected all industries, but the chemical industry as well. And then we have sustainability, which I'm sure all of us can have at least a brief idea of where this is going. We obviously are moving towards zero emission, more efficient energy. So this is also affecting the chemical industry and the trends. So for here, let's say that the main topic related to perform and this white paper would be sustainability. This will be the main trend that we will be going more into detail. So these are a few facts that we have. Okay, this is kind of where the problem statement of the white paper starts. In 2020, the chemical industry represented around 7.5% of the European manufacturing turnover. In 2018, it accounted for 17% of of the global chemical sales. That's around $500 billion. And until 2015, it provided, as you can see, a lot of highly skilled jobs. So this industry is, as we have mentioned before, having a positive impact, of course, on Europe and its economy. We also know, because we always hear from the European Commission, the European Parliament, United Nations, that there are many directives and legislations that are trying to make many industries more sustainable. For the specific case of the European chemical industry, we have the REACH directive, which is meant to regulate the registration, evaluation, authorization, and restriction of chemicals. Um, this is meant to kind of encourage the industry to change from these hazardous materials to materials that don't have that negative impact on the environment and on us human beings. There's also the European Green Deal, which is a strategy where the European Commission, let's say that the main target is to become the first climate neutral continent of the world. So they are also, of course, encouraging industries to be more sustainable and to produce less carbon emissions. And then we have the Paris Agreement, which is the objective is to achieve kind of like a global agreement so that the temperature does not increase more than 2 degrees Celsius, because as you know, the global warming is a very recurrent worry that we have all around the world. Then from Europe, they have come with these, let's say, affordable solutions for the industries to reduce their carbon footprint, because of course, it's not only about wanting to be green, it's also about it being affordable, and not meaning that a company needs to lose money with it, of course. So we have the three main, which is reducing the CO2 emissions, replacing fossil fuels in production processes, and circular economy. At this moment, these trends have a very high level of technology, but the barrier is that they still need high upfront investment. So this is the main barrier at the moment. Then on the available technologies, now speaking specifically about reducing the CO2 emissions, we have this technology list, which can be applied to current processes. So we have energy efficiency, electrification, deep geothermal energy, biomass, renewable or low carbon hydrogen, and carbon capture and storage. For the Perform project, and then for this white paper as well, we are focusing on electrification and biomass. So Perform's ambition. This is kind of like the two main legs, let's say, of what Perform wants to achieve. One is electrification, as I mentioned before, which is looking for the decarbonization of the industry, since this is one of the barriers for the targets towards climate neutrality. There's a big interest in the electrochemical industry. In the last years, this was moving slower, but as these targets come closer and closer, the electrochemical industry has been evolving and trying to really achieve this decrease of use of carbon. And then also the shift towards bio-based feedstock. We all know that we are currently in the development of a bio-based economy, especially Europe. So the concept of biorefinery, for example, is taking a more bigger and bigger role. And the focus is to enable Europe to convert biomass into marketable products and to use biomass instead of fossil-based, for example, for processes, for industry processes. So regarding the ecological print, let's say that this is a concept that depends on where you read it, but in general, I really like this image. These are of kind of all the factors that come in when seeing a certain region or a country's ecological footprint. We have forest products, carbon footprint, which is, of course, a very important part. This is the one that we hear the most, I think. And it accounts for around 60% of Europe's ecological print. But we also need to see the other factors that come in. So forest products, carbon footprint, cropland, pasture, built-up land, and fisheries. So you may be thinking that maybe the EU's ecological footprint is not having a negative impact on the world. But at this moment, if every single person that lives on Earth consume like the average EU resident, we would need 2.8 Earths in order to continue living like this. So I think that we can all agree that this is a moment where we need to actually address these topics. So the Power Platform, this is kind of like the biggest result from the project, from our project Perform, and it will allow the production of high value acids. So here you can see the specific challenges from the European Commission and how Perform will address these specific challenges. So the European Commission is encouraging non-conventional energy sources, in general, such as microwave, plasma. You can see electrochemical is also encouraged. So in Perform, we will use the electrochemical conversion to using bio-based feedstock. So this is kind of a very important step for us. And it will also allow selective conversions, especially for electrooxidation. Then another specific challenge is the process powered by non-conventional energy sources need to be suitable for connection to the electricity grid. So in this, for us in Perform, electrochemical conversions will be powered by renewable electricity or grid electricity. And it is what we want is that there are no loss in performance. Then we have to allow variable outputs to better follow market demand, to enable production paradigms. So our electrochemical reaction is stackable and modular and flexible. So the load can follow demand of the market. And then the technologies are suitable for, they want to encourage technologies are suitable for downscaling and continuous processing. And also to be coupled with real-time monitoring. So the modular design will allow the processes to be easily scaled up and down. So this is kind of like the, let's say, the main thing that's going on inside of the reactor. We have two lines, okay? The line number one, where we will use furfural and linoleic acid to obtain via a redox reaction, maleic acid and valeric acid. And then on line two, we will use glucose, which we will oxidate to get glucaric acid, and then the hydrodeoxygenation of glucaric acid will result in adipic acid. So these are kind of like the main products that we will have from the platform are maleic acid, valeric acid, glucaric acid, and adipic acid. These acids are, of course, of high value to the world in general and to Europe as well. So how will this happen? Let's say that this is a summary of the results because, of course, the reactor will be designed and also the process system will be designed during the project, but we will also achieve other things. So other than designing the reactor and integrating all the process system, this is all to, as I said before, obtain the acids that you can see in the bottom. We will also adapt this process to obtain other chemicals via other reactions. Also, the consortium will do the valorization of the product streams for new market segments. They will develop new catalyst materials, also novel electrodes for the redox reactions, and also to use these decarboxylic acids to obtain bio-based and biodegradable polymers. So who can benefit from this platform? Let's say that these are the main players that we are looking to impact, let's say, but of course, Also, the legislations and the regulations and the policies, this is all very closely related to what we want to achieve. So the first one is food and beverage industry, specifically for the fractions of glucaric acid. It can be used as green and renewable food. It also is used for supplements. And also the maleic and valeric acids, which the maleic is used to substitute sugar in confectionaries, and the valeric acid is used sometimes for flavor and perfume. Then on number two, we have agricultural chemicals. Specifically, valeric and maleic acid are in rising demand for agricultural chemicals. Then number three, the detergent industry. This is quickly adopting glucaric acid as a replacement for phosphates, right? So it is very high in demand at the moment. Then number four, we have automotive industry. There's a specific interest here for glucaric and adipic acid because these fractions can be used to manufacture nylon 66, and maleic acid can be used to manufacture polyester resins. These are what we call high performance plastics, so they can be used for cars, for example. Then cosmetics and personal care industry. This is specific for maleic and valeric acid since they are widely used to manufacture these products. They normally add fragrance or balance pH, for example. And then for research and university, the consumers of high quality chemicals could use this for research and activities because the chemicals that will be produced with the power platform, the objective is to make them a very high quality product. So in this case, they can also be used for research, which have, of course, very specific specifications and things that they need so that the research goes well. So if you want to know more, please check out the white paper that we produced from the Perform Consortium. You can find it and take a look at it. And if you have any questions, please be sure to let us know. This is Carla Sebastiani from Sustainable Innovations, and I hope that you like the work that we are doing and that you read the white paper. Thank you.